All right, guys, there's the practice final video for you guys to watch. So question one, okay, we're just starting with the unit circle here. So you just got to drag everything in. Again, we obviously open resource, so no reason to miss anything here. You can double check your work, but you should try to see what you guys know. So, I mean, if you started obviously at 0, okay, you're just dragging that in, and then it's also 0 radians. Okay, and then what's that point? Well, this is an easy point, right? It's on the x-axis, so the x is 1 and the y is 0. Oops, goes in there. All right, so that's an easy point. What's another easy point is the one on the y-axis. That's going to be the point 0, 1. And the y-axis will be 90 degrees. Oops. And that's at pi halves. Oh my goodness. All right, so now looking through here, remember we're always doing with our special right triangles here. So going in order, this triangle would be 30 degrees, this angle here 30 degrees to make that triangle. Then we have our 45, 45 triangle in the middle, and the other one would be a 60, 30, 90 triangle. So again, those triangles are the same, just flipped. Okay, so then our radians, okay, remember it's 30 degrees times pi over 180. Okay, so I mean, the math, it's always degrees times pi over 180 to convert, right? And so if you did that, right, that would be, you reduce that fraction, right? That's pi over 6. All right, so 30 degrees is pi over 6. And so that's the process that you're doing. I mean, or you just, if you've remembered it from doing it so much, right? And then 45 degrees would be pi fourths, and 60 degrees would be pi thirds. And then when you're dragging in here, the points, again, you could sit here and draw your triangle. Oops, pretend that was neat, right? If that's 30, we know the hypotenuse is 1, okay? And then the side opposite 30 is half that. So this height is 1/2. So our y point has to be 1/2. All right, and then the other side is short side times rad 3. So rad 3 times 1/2 is rad 3 over 2, and that goes there. All right, and then they've got to be flipped for this one. And then 45, 45, that triangle, okay, will be rad 2 over 2. And then since it's the same for both, they're both rad 2 over 2. All right, so we're just dragging in, okay, using the work right there. Next problem. All right, converting between degrees and radians. So I just kind of talked about this. All right, what's the rule? Okay, so it's the degrees. Okay, so whatever your degree is times pi over 180. Okay, is going to equal your radian. All right. Okay, so I put x there, but usually we use theta. And then vice versa, right? If you have your radian, okay, so theta rad, and you're just going to multiply that by 180 over pi, and that's going to equal your degree. All right. that's all we're doing here. Okay, so 45 degrees. Plug that in, 45 over 180. What's that going to simplify down to? All right, and that's pi fourths. The pi, I always leave everything in terms of pi. Okay, so pi, nope, is the fraction bar in there. Here we go. So pi over 4. So you're going to type in there. Okay, 90 degrees, so 90 over 180, that's 1/2, so pi halves. Pi over 2. And now we have 7 pi 6. Okay, so now you're going to plug it into here, so the pi's will cancel out. 6 goes in 180 30 times. 30 times 7 is 210. This is going to be 210 degrees. And you do not need the degree symbol. Okay, so we're reading the directions. 3 pi halves, that's 270. That's right off the unit circle. All right, 300 degrees, that's also on the unit circle. All right, but if you're going to plug it in here, 30 over 18, so 6 goes into both of those, 5 pi thirds. Fraction going, and 5 pi thirds. All right, and so there you go. This is how you convert from degrees to radians, or vice versa, radians to degrees. All right. I'd like to clear, how do I clear all that? Last time it just went away. All right, so now this question says, for which quadrant or quadrants, okay, would both sine and tangent of the angles result in a negative value? Okay, so sine and tangent, so both of them. So sine is the y value, so that limits us to quadrants 3 and 4. The only time sine is, but tangent then would only be negative in quadrant 4. Okay, so we're just picking quadrant 4 right there. All right, and again, because quadrant 3 is they're both negative, so tangent ends up being positive there. So even though it says select all quadrants that apply, okay, only one is true is quadrant 4. Okay. And then evaluate all 6 trig expressions, okay, for theta equals 3 pi fourths. Okay, so if you're looking at your unit circle, 3 pi fourths would be in quadrant 2. All right, and so that's going to be our rad 2 over 2. But since it's quadrant 2, that means our x is negative and our y is positive. So we just got to type all these in over here. All right, so we got our fraction bar. All right, we got rad 2. Oops, my radical sign. Rad 2 over 2. Okay, and then cosine. Oops, that's not good. It would be negative. Negative rad 2 over 2. Again, this is in quadrant 2. Okay, and so the point that corresponds with that, let me write that up there, the xy points, right? It's negative rad 2 over 2, comma, positive rad 2 over 2. All right, so these are the points that I'm using okay, for this. So the y is positive, the x is negative, right? And then tangent, okay, will be just -1. Okay, so when you divide those two, and you're dividing the same number by itself, obviously it's just 1. It's negative divided by a positive, so it's negative. Cosecant is just the reciprocal of this. So the reciprocal of that is just rad2. And again, the math for that, I'll do that real fast. Okay, the math, okay, the reciprocal is 2 over rad2. Can't have a radical on the bottom. So you multiply the top and bottom by rad2 to rationalize the denominator. All right, and then on top you get 2 rad2. On bottom you just get 2. So obviously you simplify and you're just left with rad2. And that's where that rad2 is coming from. All right, and then here, okay, obviously it's the same thing, just gonna be negative rad2. And then cotangent reciprocal -1 is still -1. All right. And so that is how you're gonna do all 6 trigs of those. Just erase my hand every time. All right, now we're going to do 210 degrees. So same question, 210 degrees. So you're looking at, okay, what quadrant is that in? That's going to be in quadrant 3, right? I know that because it's bigger than 180, less than 270. All right, 210 is 30 degrees bigger than 180. So the point's going to correspond with 30-degree angle in quadrant 1. Okay, which is rad3 over 2 comma 1/2. But since it's in quadrant 3, we know that it's both negative. So we're 210 degrees on the unit circle is negative rad3 over 2 comma -1/2. All right, so that's our stuff there. All right, so when we go in and we type all this in, that's all we're doing here. Sine is going to be -1/2. Put that negative in front there. Cosine will be negative rad3 over 2. Tangent, I've got to divide, okay, y divided by x. So when you divide both of that, okay, so you're going to multiply by the reciprocal. So it's going to be positive, but it's going to be 1/2 times 2 over rad3. Okay, and so you end up with 1 over rad3. All right, and then you have to multiply the top and bottom by rad3 to rationalize it. And so you get rad3 over 3. So that's my tangent. Tangent is going to be rad3 over 3. Right, cosecant, this one's easy. Okay, reciprocal of 1/2 is just 2, so reciprocal of -1/2 is -2. Okay, secant, okay, again, I've got to flip it, so it becomes 2 over rad3. You rationalize it, it's going to be 2 rad3 over 3. And this will be negative still. I should put the negative first. Oops, I'll go back and do that. 2 rad3 over 3, the negative out in front. Cotangent is just going to be rad3. Reciprocal of that. So you just look down at my work here. At one point, it was 1 over rad3. So you flip it there, it's just rad3. And that's positive. So for quadrant 3, 210 degrees, right? Your sine, cosine, cosecant, secant are all going to be negative. Your tangent and your cotangent will be positive. All right, next one. All right, so here we're going select the correct period for each trig function below. So if I look at my notes, okay, how do I find the period based if I don't have a graph? If I had the graph, right, I could just count, right, from max to max on sine and cosine. For tangent, it looks how far away are the asymptotes. But we don't have a graph here, and I don't want to sit here and type these into Desmos. So I need to remember the period, okay, for sine and cosine, all right, is 2 pi divided by the absolute value of b. Okay, and for tangent, again, that's sine and cosine right there. And then for tangent functions, which that's on here as well, it's just pi over b, absolute value of b. And that's how you find your periods. Again, b, okay, is the number being multiplied, okay, to your x minus h. All right, so the b will be in the parentheses. All right, so for this first one, b is 2. It's tangent, so it's pi over 2. Okay, sine, b is 4. So it's 2 pi over 4, which reduces to pi halves. Okay, for the next one, b is 1. So it's just 2 pi. All right, and then for q of x, b is pi. Okay, so that means it's just 2. Okay, and for h, b is 1/4. Okay, and this is on sine, so that's going to end up being 8 pi. 2 divided by 1/4 is 8. Okay, and then for r of x, b is pi halves. Okay, and it's on cosine, so 2 pi divided by pi halves is just going to end up being 4. All right. And so that's how you do periods for the trig functions that we learned. All right, key features. Why this stuff keeps popping up. All right, so what are the key features here? What are we looking for? All right, so we got, what is the amplitude of the graph? All right, so the equation is not given to us, so we can't just go, okay, what's A? So what we have to do is we have to find the midline, okay? So the midline here is at -1. So let me get the pen out here. So you can see the midline is right here at -1, right? And so the distance from -1 up to 2, that's a distance of 3, right? You can check with the min too to make sure you're really right in the middle. It should be the same distance, and it is. So my amplitude is 3. Midline, so we just identified that. That's -y equals -1. The period, okay? So now we've got to just look, okay, from max to max. So you can do from min to min, okay? So the period here is 2 pi. All right, the maximums start at 0. Okay, 2 pi, they happen every 2 pi. Okay, and it's up at 2. So it's 2 pi k, comma 2, where k is an element of the integers. All right, and now we want to drag, okay, what is the domain? So the domain is for sine and cosine functions is all real numbers. And so this one, the correct answers may be written in different appropriate forms. Be sure to find them all. So it's another way to say all real numbers. Yeah, so make sure you click both of those. The range, though, right, is limited from the low point -4 to the high point 2. Okay, so our range is from -4 to 2, and they're both included. So you got to make sure you pick the one that's in brackets. And there you go. So bracket -4 to 2. Which of the following is the function of the given graphs? All right, so I if I can move this out of the way here. All right, so we know that the amplitude is 3, okay, and we know that k is -1. All right, so we are either talking about A or C. All right, so let's plug in 0 and see what we get. When we plug in 0, okay, we should get 2. So we're just going to test it out, okay? So sine of 0, okay, is what? And cosine of 0 is what? So then looking at your unit circle, sine of 0, at 0, the y value is 0. Okay, and then so that would be 0 times 3, 0. So that's not going to be that one. So it should be C. Let's just double check. Cosine of 0 is 1. 1 times 3 is 3. 3 minus 1 is 2. So it's going to be C. All right. All right, so here, okay, really this is like our interpreting functions stuff, understanding transformations. All right, so you're going to drag the shift over, okay, and there could be more than one that fits into it. Like when there's a negative, you know it's reflected over the x-axis, but it also has an a in there, so it's going to have a dilate or stretch factor, okay, of a, so of 6. All right, so now g of x is being reflected, but then it's being shifted up 6 units. Got a k is 6. So again, what we're looking at here, let me just take the time to write it up here. All right, we have all of our transformations here, right? It's a, right, times f of x minus h plus k, right? So the k is always outside the parenthesis, being added or subtracted outside the parenthesis. The h is always inside the parenthesis, and the a is always being multiplied to the f of x part. Okay, so this 6 right there is clearly the k, so it's up 6 units. Okay. Now, in this third one here, that's the h, right? It's being shifted 6 units to the right. Right there, sorry, I couldn't find it. Shifted right 6 units, and then the k is -1, so then down 1. All right, on g of x, we got a negative out in front again. Okay, so that's another reflection. And then it's shifted to the right 6 units. All right, we got another negative out in front. Okay, this one's shifted to the left 1 unit and down 6 units. All right, so just making sure you guys understand how we shift things. We did it with trig functions this semester. We did it with log functions, with exponential functions, with the radical functions. Okay, just in this unit alone, this semester alone, we did all that stuff. Okay. All right, solve the equation. Remember to check for extraneous solutions. So an extraneous solution is a solution you get, but when you plug it in, it's not part of the domain of that function, meaning that you plug it in, you can't do the square root of a negative, right? And when we're solving here, right, it needs the principal root is all we're looking at here. All right, so if we do the work, add 6 to both sides, we get square root of n plus 5 equals 10. Square both sides, you get n plus 5 equals 100. Subtract 5, and you get n equals 95. And that, okay, you plug in 95 in there, you get 100. Square root of 100 is 10. 10 minus 6 is 4. So that is correct. That does work. All right, here for number 2, all you're going to do is square both sides. Okay, and so when you square both sides, right, the radicals go away. So you get 2r plus 9 equals r plus 9. And then subtract r from both sides, subtract 9 from both sides, and you end up getting r equals 0. And that works when you plug it back into check. You get 0 plus 9, 0 plus 9. Okay, now number 3, I square both sides. I'm going to end up with a quadratic here. So now I'm going to end up with 20 minus x equals x squared. So when I get this quadratic, okay, how do I solve a quadratic? I set it equal to 0, so I'm going to move everything over. So I get x squared plus x minus 20 equals 0. This is factorable. What multiplies up to negative 20 and adds up to 1, so that's going to be x plus 5 and x minus 4. So I get two answers, negative 5 and positive 4. Can equal to. So negative 5 does not work because when you plug it in, you're going to get square root of 25 equals negative 5. And we're only principal roots only here, so that's not true. 4 does work. 20 minus 4 is 16. Square root of 16 is 4. So the answer that works is positive 4. Negative 5 does not work. All right. Okay. Now we got logs here. Place the logarithmic expression, okay, with the value they are equivalent to. All right, so with logs, okay, you got to understand that a log is an exponent. All right, so what do I mean by that? So if I have like b, right, to the m, right, equals n, okay, this is an exponential equation here. We got a variable that's in as an exponent, right? B's are base, m's are exponent, and n is whatever it equals, right? So we could write this in log form, okay? And the log form gets the m by itself. So in log form, right, it's m equals log base b. The base doesn't change, right? You pronounce it log base b. It's like a subscript down here of n. And so a log is an exponent. You can clearly see m was the exponent when it's in exponential form. And when you write it in log form, it's n equals the log. All right, so when we're looking here, log base 5 of 125, what is that asking? That is asking me 5 to the what power equals 1 over 25. All right, and so that answer will be negative 2. And that's all we're doing. 7 to the what power is 7? 7 to the first power is 7. So that's 1. Log base 9 of 1/9. That's going to be negative 1. Log base 2 of 1. So 2 to the 0 power equals 1. 3 to the negative first equals 1/3. 2 squared equals 4. So 2. 2 to the third equals 8. 2 to the first equals 2. 2 to the negative second equals 1/4. 3 to the negative third equals 1/27. 3 to the 0 equals 1. And 3 to the positive third equals 27. So again, once you understand what a log is, especially with these numbers, they're very easy because they're all perfect powers, okay, perfect roots. So it's when it's not, okay, then you'll need your calculators to approximate your answers. All right, now we want to match the function with its corresponding graph. Okay, so our choices are down here. All right, and so when you're graphing log functions, right, log functions have a vertical asymptote. All right, so where's the vertical asymptote at? It's going to be at the h. Okay, the h value tells you the vertical asymptote because you cannot do the log of 0. Okay, so it doesn't exist right there. And you can't do log of negatives either. So obviously the graph doesn't exist anything to the left of the vertical asymptote unless the graph was reflected, which we don't have in this case. So this first one has a vertical asymptote at -2. It's the only graph on here that has a vertical asymptote at -2. So I'm looking for the graph that has an h of -2, which is this first one. So I'm going to drag that up there. Again, the h is -2. Remember, the h is the opposite of what you see there. So it's going to have a vertical asymptote at -2. All right. This graph right here has a vertical asymptote at +2. And it's the only one that has a vertical asymptote at +2. So now I'm looking for the h, okay, that has that +2, and that's this one right here. All right. Now, only one of these is going the opposite direction where the right end behavior is -infinity. So that means it's been reflected. So now I'm looking for an a that has a negative a, and there's only one there. All right. So now we have 3 graphs, okay? They all have the same vertical asymptote. This one looks like it's been stretched out. It's growing faster. This one just looks like the parent function, right? And this one looks like it's been shifted up a little bit. It's hard to tell exactly, but that's what's going on here. So if you just checked, like you plugged in 1, okay, what am I going to get? Okay, so log, natural log doesn't matter, right? My y is going to be 0 there. All right, so both of those there, but see how that's different? That's stretched out, right? So this one will have the 5 on it. This one will be just a regular parent function for natural log. And then this one will be shifted up to. All right, so what is this one saying? This one is saying select the correct right and left end behaviors for each of the 8 functions, and for the exponential function, select whether it is exponential growth or decay. All right, so growth, okay, means that the b is bigger than 1. Decay it's between 0 and 1. And so you got to pay attention to this because there's easy ways to trick you here. So like 2 to the negative x, okay, is the same thing. It's as 1/2 to the x, okay, and so here we have decay, And so then my right end behavior will just be going towards 0. And my left end behavior goes up to infinity. Right there. All right, 1/3 x, okay, minus 3. So again, this is decay. Now the asymptote is going to be at -3, so the right end behavior is going to be -3. But it will go up. The left end behavior will go up forever. All right, C, that's growth. Okay, my right end behavior will go up forever now because it's growing, and my left end behavior will approach 0. All right, E is positive, so that's growth, or bigger than 1, so that's growth. Okay, horizontal asymptote is still 0, so that's going to be the same. My right end behavior goes up, my left end behavior approaches 0. All right, so now we have a log function. So log of x minus 3. All right, so we don't have to answer the growth or decay part anymore. The right end behavior, okay, is going to be going up to infinity. And the left end behavior is going to be going down towards negative infinity. Same thing here for G. I'm sorry, I got to fix that, sorry. So instead of saying the left end, because it doesn't exist there, as it approaches, so that one, so as it approaches 0, okay, so remember there's a vertical asymptote at 0, so the domain doesn't exist past that. And click the wrong thing anyways on that one. So as it approaches 0, it's going to go down. Okay. Now for G, okay, it's been shifted over to the right 3 spots. So you're going to say as it approaches 3, okay, it's going to go down forever. And the right end behavior is positive infinity. And then 3 log of x. Okay, so again, okay, the asymptote is at 0. So the left end behavior, so to say, as x approaches 0, it goes down, and the right goes up. All right, drag and place the expression that is the correct value of x for the given 4 equations. All right, so we solve these. All right, we're going to rewrite in log form. So x equals log base 9 of 75. All right, just rewriting it. X is by itself. Okay, and so that's what we're going to grab without. It's one of our choices. Right. Now, if it said round to the nearest 10,000th, we just type that into our calculator and round. All right, so 2, the log base 15 of 64. Okay, here we should actually be able to evaluate x here. It's because we rewrite it. Put my pen back on. 9 to the 0 equals x. So what's x? Okay, anything to the 0 power is 1, so x is just 1. All right, and then 4 is 5 to the negative second, which is 1 over 25. All right, select the function that matched the given criteria. All right, so we got y-intercept of 49. We got right end behavior approaches 14. Left end behavior approaches infinity. So here we've got exponential equations here. All right, so when you're doing this, all right, to find the y-intercept, you can just plug in 0. But these are all going to be decay functions, all right? Because even when b is bigger than 1, there's a negative exponent, which means you're taking the reciprocal of it. All right, so the right end behaviors for all these will be approaching the horizontal asymptote, which will be your k. All right, and so for this first equation, if you plug in 0, right, you're going to get e to the 0 is 1, so you're going to get 14 plus 35 is 49. And then my k is 35, so my right end behavior will approach 35. So that's going to go right in the middle. Okay, here, same thing, 35 plus 14, so my y-intercept is 49, but now my right end behavior is going to approach 14. All right, here you plug in 0, you get 35 plus 49, so that's a y-intercept of 84, so that's the only choice there. And again, but my right end behavior will, okay, approach 49. That's my horizontal asymptote. Here, again, 35 plus 14 is 49, and the horizontal asymptote is 14. And then here, it's 35. There we go. Okay, order the given steps from first to last that were used to solve. All right, so if I was solving this, okay, the first thing I would do is subtract 3 from both sides. So this one's going to be first. So now we're at this point. All right, and then we're going to have to rewrite it as a log. Oops. Boom, and then 5 to the 20, that's just 2, so we're going to simplify that. Then we got our answer. Okay, solve each equation. All right, so when we're solving log equations, okay, you want to get one log, you want to isolate the log and then rewrite it as an exponential. So here we have 2 logs we're subtracting. So when you're subtracting logs, you write it as 1, you condense it as 1 log by using division. So this is just log base 8 of 4x over 3 equals 1. And now I could rewrite it 8 to the first, which is just 8. So 8 equals 4x over 3. Multiply both sides by 3/4, and x equals 6. All right, now with addition, it's very similar, but now when I condense it, I multiply together. Okay, so I got to multiply x minus 9 times x minus 10 together. So that's a FOIL problem. I got to FOIL that together, double distribute, right? So when I do that, I'm going to get x squared minus 19x plus 90 equals 1. Rewrite that. So 2 to the first, which is just 2. So 2 equals x squared minus 19x plus 90. Now it's a quadratic, so I want to set it equal to 0. So 0 equals x squared minus 19x plus 88. Okay, solve that by factoring. So that's going to be x minus 8, x minus 11. So my answers are 8 and 11. And then 8 does not work because when you plug in 8 back into the original problem, 8 minus 9 is -1, so you can't do a log of a negative. So the only answer that works is 11. Okay, so it looks like we got some empirical rule here. If I can erase this or not. Okay. So it's quite, it says the trunk diameter of a certain variety of pine tree is normally distributed with a mean of 150 centimeters and a standard deviation of 30 centimeters. Okay, sketch a normal curve that describes this distribution by labeling, okay, the image below correctly. Not all options will be used. All right, so when we're labeling the normal curve, we're going to put the mean in the middle. So the mean was 150. And then each standard deviation is 30, so you just kind of count by 30s here. 180, 210, and another standard deviation would make that 240. And then coming smaller, subtract 30, so 120, then 90, and then 60. All right, and then you got to know that 68% are going to fit within one standard deviation. So 68% of the different variety of pine trees will be between 120 and 180 centimeters. Okay, and then you have your 95% between two standard deviations, and your 99.7 between three standard deviations. Just erase that. Okay. So there's the picture, okay, that we just labeled. Okay, so given the scenario below, okay, so we got all that. Okay, use the empirical rule to complete the statements below. So what percent of these particular pine trees are between, okay, 120 and 150? So that's one standard deviation below. So it's half of the 68%, right? So it's 34%. Okay, 68% would be between 120 and 180. So that's half of that. And move this out of the way. Okay, what percent of these particular streams are between 90 and 210? Okay, so 90 and 180, right? This is 68% for here. All right, and then we got to add this section on. So what is that section going to be? All right, so what we do know is from here to here, okay, it would be 95. So how much bigger is that? So 95, okay, minus 68, okay, is going to give me 27. And I want half of that, so that's 13.5. So if I add that to 68, okay, what am I going to get? Oh, I misread that. It says between 90 and 210. So that's an easy. I did way too much work. I was doing from 120 to 210. So my bad. That's just going to be 95%. All right. So what I was doing, okay, was 120 to 210. All right, and that would have been 81.5%. Okay, what percent of the particular pine trees have a diameter between 60 and 240? So again, that's 3. So that's just going to be my 99.7. Okay, and then what percent have at least 150? So that's half. All right, so there's your empirical rule right there. Okay, now we say CHS wanted to know how many Puma Pride shirts to buy for next year so they would not run out in the first few weeks. They surveyed the entire school population, 3,000 people, to see how many shirts each individual would want to purchase. The following table illustrates the results of the survey. Based on the survey results, how many shirts should they purchase to ensure they have enough? Okay, so 15% are not going to buy the shirt. Okay, so that means that 85% will. So what you need to do is, what is 85%? So 0.85% times 3,000. Okay, and so at 0.85%, that's 85 over 100. So you get really just 85 times 30. So 2,550 should be the number. Okay, based on the survey, how many individuals? Oh, you know what? I didn't even read the whole question. I got to erase that. I didn't do that right. My bad. I thought those were sizes. Number of shirts. Let's erase that. Read the question. Okay, so 65%. Okay, want one shirt. Okay, so what is 65% of 3,000? So again, we'll just do that work again, but with 65. So that's 65 over 100 times 3,000. Right? So 1,950 people are going to order one shirt. Okay. 15%. Okay, so 15, that's going to be 450, but times 2, right? So 450 people are going to get 2 shirts, so that's going to be 900 shirts. Right. And then 5% want 3. 5% is going to be 150. They want 3, so 150 times 3 is 450. Okay, so you add all that up, that's going to be my answer for that first question. So add that up, what do I get? I can read my answer, so it's 0, 10, 19, 23, so 3,300 shirts. All right, based on the survey, how many individuals wanted 3 shirts? So 150 is what we got there. 5% of 3,000 is 150. All right, and there we go. That was it.